To finish up this section, we're going to find the equations of the asymptotes. So far we've been talking about graphing the cosecant, secant, tangent, and cotangent curves, and we kind of found that these graphs are very similar to the sine and the cosine, but the thing that's different about these graphs is that they have asymptotes. So whenever we want to find the equations of the asymptotes, really what we're asking ourselves is, what is the domain? Okay, so we can easily find the domain of the function of these functions really easily, not even having to graph them. Okay, so graphing them actually is not important. We can easily find it by just having the equation. So we can find the domain and we can see where the asymptotes are going to be at. So the way that we do it is it's very straightforward. So a couple of things that you should have seen is that when you go back to the notes in the cosecant curve, you saw that all of the asymptotes, so remember that the cosecant was just basically the 1 over the sine. So wherever the sine was 0, that's where you got the asymptote. So if you look at the cosecant curve, you see that you get an asymptote at 0, then you get another asymptote at pi. Okay, because that's where where the sine is 0. So basically, the equation of the asymptotes for this guy is going to be every pi units. Here, this value of k is an integer. So basically, if remember, an integer is a positive or negative whole number. Okay, so I can only plug in whole numbers in there. So for example, if I say k is equal to 2, so when I plug in 2 in there, x is going to be equal to 2 pi. That means that there's going to be an asymptote at 2 pi, which means that x cannot be equal to 2 pi there because there's going to be an asymptote. So that's basically what it means. So every k units, you're going to, every multiple of k, you're going to be, or every multiple of pi, and then k being an integer, you're going to be able to see an asymptote. And the same holds true for the cotangent, which we kind of just did in the last video. You can see that the first asymptote is at 0, and then every pi units, you tend to get another asymptote. So that's basically the equation. For the secant and the tangent, they're very similar to each other. You can see that it doesn't start at 0, because if you think about the secant is just a 1 over the cosine. The first time that we see a vertical asymptote is at pi over 2. So you can see that every pi over 2, and then if I add pi units, I'm going to get another asymptote, because after pi over 2, the next asymptote is at 3 pi over 2. And that is found by just adding pi to pi over 2. And that's how you get 3 pi over 2. That's why you have this plus pi k. Okay, and k again is just another integer. Okay, so here are the equations. So what I really want you to be able to do is be able to know these guys, know what these equations of the asymptotes are, because we'll be able to figure out the equation of an asymptote for any given trigonometric function. Now clearly sine and cosine are not here because there's no equations of asymptotes. Now this is only when you have an x in the inside. What about if you don't have an x in the inside? You have a phase shift or a vertical shift or something like that. How does that influence the equation of asymptotes? So here what I did is that I figured out, I gave you guys a couple of rules. So the first thing that you want to do is identify the trig function. So you want to identify which of these functions am I dealing with. Okay, look at the argument of the function. Okay, so look at the inside. Plug that into the x. So for example, if I have the tangent and I had a 2x in here, then I'm going to plug in 2x wherever I see an x. Okay, then what you're going to do is solve for x. The outcome is the equation of the asymptotes, which is basically equivalent to finding the domain. So the domain of the trig function is going to basically be finding the equation of the asymptotes. Now this type of equation is not, or these types of equations are not in interval notation. There are in something called set builder notation. So maybe you might have heard this in Math 96. So it's just a different type of notation, but just finding these equations are just good enough. Okay. All right, so the first thing that we want to do, let's do a couple of examples. So find the equation of the asymptotes. So the only thing that's really going to affect the equation of the asymptotes is the x values. So you always just want to look at the argument. I don't care about what's happening on the outside, the amplitude or the vertical shift, the d value, that doesn't matter. The only thing that matters is the inside, okay? So find the equation of the asymptotes. Okay, so here we are dealing with cosecant. So let's look up to our little chart. Cosecant, the equation of the asymptotes is x is not equal to pi k. Okay, so x is not equal to pi k. That is the equation of the asymptotes. So now what you got to be able to do is you need to find the inside. So the inside is this 2x minus pi over 2. So that, you're going to plug it into the x. So 2x minus pi over 2. That's going to be equal to pi k, or not equal to pi k. And now what you want to do is, now that we plugged in the argument into x, we're going to solve for x. So the first thing that we're going to do is add pi over 2 to both sides. Notice that these are not like terms, so you can't really add them together. So you're going to have 2x is equal to pi over 2 plus pi k. So this is not equal to. And then we're just going to divide everything by a factor of 2. So x is not equal to pi over 4 plus pi over 2k. So basically what this means is that you're going to get an asymptote at pi over 4. And then the next asymptote is going to be pi over 4 plus pi over 2. Then after that, it's going to be pi over 4 plus pi over 2 times 2, and so on and so forth. Because k here can be a positive number, and it can also be a negative number. Okay, it can be all of these numbers. Okay, all right, so that's the equation of the asymptote. Okay, so now let's do part B. So part B, we have cotangent in this case. So let's find the equation of the asymptote for cotangent. So cotangent in this case is, again, x is not equal to pi k. So we're going to write that down first. X is not equal to pi k. We're going to go ahead and substitute the inside, because we don't care about what's going on the outside. The outside is doing some weird things. We only care about the inside. We're going to plug that in here. So we're going to have 3 pi x plus pi over 4 is not equal to pi k. Okay? So let's solve for x. So I'm going to subtract by pi over 4 to the other side. Okay, so you're going to have 3 pi x is not equal to negative pi over 4 plus pi k. All right, and then we're going to divide everything by 3 pi. Okay, so this is going to go away. So I left with x is not equal to. Okay, so here you're going to have, what is this? Negative 3/4 plus pi over 3k. Okay, does that look correct? Totally not right. This should be 1 over 12. And then here the pi's go away, so I'm left with 1/3. Okay, that's totally not right. Okay, so this should be the answer. So here where all the asymptotes should be. I wasn't multiplying right. Okay. Okay, so yeah, the pi's go away, and then you have 4 times 3 is 12. Yeah, okay, everything's good. Okay, so this will be the equation of the asymptote. So remember, you're only looking at the inside part. Okay, so now let's do this last one. So we have a secant. So remember that secant, if you look here, this is the equation of the asymptote. Okay, so we have x is not equal to pi over 2 plus pi k. Now in this case, what we're going to plug in is this 2x minus pi. Okay, not equal to pi over 2 plus pi k. All right, so now let's go ahead and solve for x. So we're going to have 2x is not equal to, okay, so I'm going to take pi over 2 and I add pi. That's going to give me 3 pi over 2 plus pi k. And then finally, I just divide by 2. So I'm going to have that x is not equal to 3 pi over 4 plus pi over 2k. Okay, and that's going to be my equation of the asymptotes. Okay, so this is kind of very straightforward. As long as you have this little box here, you'll be able to find out the equations of the asymptotes. I kind of made a big mess here. But yeah, so you have these equations, so make sure that you know these equations by heart, hopefully. They're not really difficult. The C's are basically the same, and then the other ones are just with the pi over 2. So they're not that difficult to memorize, and they're also not that difficult to solve for. Just make sure that you only look at the inside of the argument. You don't care about what's going on the outside.